All right, guys, so this should look familiar to you. This is the side of the building where we decided to drop our packages from. So what you remember from class the other day is that's not it. That's not it. That's not it. Here we go. So remember we watched this video? And he's talking about how we can calculate acceleration with using a meter stick and a light. Now, we don't have the ability to do that because I didn't have the ability to have a tape measure taped from here down to the ground. I didn't have one long enough at the time. They do make some that are long enough, but I didn't have access to one, okay? So, but we still want to be able to show or prove Newton's second law of motion with this. So what I did the other day, obviously, is I went out and I took a picture, because you have this, of the side of the building. This is where we dropped our stuff. And I measured the bricks, okay? So and you have this, it's much bigger, but each of these bricks is 19 centimeters wide. The height of them is 5.5, and the mortar, or the white spacing between, is 1.4. This large concrete hump down here, this is 14.5 centimeters tall, okay? So now, since that guy had the ability to have a meter stick placed there, okay, it made things a little bit easier. We have to put in our own meter sticks, okay? You have video footage, okay, so that's not the issue. But what we're going to need to do is we're going to need to take this piece of paper, and you're going to need to plot your points for each frame on this sheet of paper so that we can figure out the distance, and then we'll come back and we'll figure the time and the speed and the acceleration, okay? So how can you do that? How can we figure out if this, I said the height is roughly 25 feet, okay? But science doesn't go by feet. We go by meters per second, okay? So we're going to have to do some calculations here. So how am I going to figure out if I drop my box from here, okay, and it goes down at each frame, if my first point is here and my second point is here and my third point is here and my fourth one is down here, how am I going to figure out what's the distance at each of these points? Okay, one of the things that he talked about was, as your box, his was a light. As it drops, you would measure from the very, very, very top. Okay, so if your box is here, you're not going to put your dot here. You're going to go here, because the entire box has gone past this point. Okay, so what you're going to have to do is you're going to have to figure out how many bricks do we have in each section. Okay, how many rows of mortar do you have in each section? We're going to do a lot of multiplying. Okay, here's my scribbles so far. So here was my first one. So ignore my dots here and my lines here. So I went through and I counted how many by 10. I have 10, what am I doing here? So down here, oh, here's my pencil marks. So I went through and marked in pencil. It's really hard to see on here, but I kind of marked it out. So I counted by bricks. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10 rows of bricks, okay? And in between those, I have 10 rows of mortar. And then I just, oh, and that's what I did here. So then I have 1, 2, 3, 3 rows of bricks, and then I have, and all that stuff. So I would just count, and then this big section here, I divided it up by 10. So how many rows of bricks and how many rows of mortar. Then what I did, as you can see, I kind of up here in blue, I started, so with 5 bricks, if each brick is 5.5 centimeters tall, 5 rows of bricks times the height of that brick gave me 27.5. Okay, from there I figured up how tall would 6 rows of mortar be. 6 rows of mortar at 1.4 centimeters each gave me 8.4. So this chunk right here was 35.9 centimeters thick. And then I just kind of went by piece, because the goal is I want to be able to mark on my sheet of paper where is each meter. Okay, so this chunk right here, now these bricks were turned vertically as opposed to horizontally, so I would need 19 times 2, okay, plus the mortar in there, so that gave me 39.4, and then I added those up. So if I had, I'll show you here, don't mind my kids reading goals, so 35.9 plus 39.4 plus 13.8. So it gives me 89.1 centimeters. 1 meter is 100 centimeters. So what I did from there is I just, one at a time, I'm sure there's a better way to do this, but I added 5.5 for one more brick. Okay. Oops. Let me go back and do this again. Plus 39.4 plus 13.8 equals, okay, plus 5.5. So that put me at 94.6. After a brick, I have mortar. So what is going on here? 35.9 plus 39.4 plus 13.8 equals plus 5.5 equals plus row of mortar, 96. So there's 1 plus, okay. So 101.5, that's a little bit over a meter, but on my picture I'm not going to be able to get exact. So if this part here was at 13.8 and I had a brick, a row of mortar, and another brick, here's where I drew my line. So at the end of that brick is 1 meter. Okay, so then I would kind of do the same process to figure out where would 2 meters be, and I would draw a line on that and mark that as 2 meters. Once I get finished up with that, I'll know how many meters tall is my building. Okay, then what we're going to do is we're going to scale this down. Okay, so that'll be in another video once I get this finished. Okay, questions so far? I know you can do this. The goal, like I said, with this is we want to figure out that on each frame on your video, okay, on each frame on your video, you'll have your markings. Let me find another picture here that I haven't drawn on yet. You'll find, so if you have, where did we say 1 meter was? 1 meter was, here's 1, 2, 3, 4, okay? So here's 1 meter. So on your video, let's just say that here's where 2 meters is. I don't know that for sure. So let's say on your video that you're watching, and so you start up here at the top. This is where she's dropping it from. Then you click forward 1 frame, and it's here. Okay. Then you click forward another frame, and it's here. Then you click forward another frame, and it's here. So we would need to measure at this point, at your first point, what's the distance that it's dropped. The second point, what's the distance that it's dropped, and so on and so on and so on, so that we can calculate the velocity, and then we can go back and calculate the acceleration. Okay, because as we want to see, as your box travels, does it stay at a constant speed? Does it accelerate? Okay, we also want to find out and compare between our boxes and another group's boxes. Does mass affect the amount of acceleration? Okay, so there's part 1. Good luck. You can do it.